Okay. I assume I didn't see any response in the chat box. Okay,
Uh,
great.
so
So let's assume, yes, yes. I think there was maybe a drop in signal or something. So let's assume this data that you're looking at here. Ignore this C1, C2 for now, okay? Ignore what is written here at the moment. I'm going to delete this one for now so that it doesn't confuse you. So how many data points do you have? How many data points do you have in your data? 1, 2, 3, 4,
6.
5, 6. 6 data points, right? And how many attributes does your data have? I'm going to change the color of my pen. I think red is better here. So how many attributes do you have? It's 2 attributes. That's correct. Ahmed. So now, what was the first step in in your algorithm? Where do you start? Where do you start? You have to choose randomly a set of k instances, which means that I need to tell you, how many clusters I'm going to give you a try. So for now, because we haven't covered that, how we pick that. So I'm going to, your manager has already given it to you. K equals to 2. K equals 2, right? So it is already given. So what is the next step? You have to pick those 2 points randomly, which means what? Which point can you pick potentially? Which point can you pick potentially out of these? Well, the answer is that you can pick any of the two. So when I picked 1 and 3, it was a random choice. It does not have to be 1 and 3. It could be 1 and 2, 3 and 4, 1 and 6, 3 and 5, any or two, any of the 2 points. You all okay with that? You all understand what I'm doing? So these are
Yes.
just randomly picked points. It does not have to be 1 or 3. It could be any random points. So once the random points are done, so who can tell me the coordinates for C1? What is the coordinates for x comma y for C1?
1 and 1/2.
1 and 1.5. So you must understand that point 1 on itself is there, but on top of it, we have considered another point called C1, which is the center. You understand what C1 is? So 1 is not C1. C1 is actually sitting on top of point 1. Do you understand this very important subtle point, right? So T1, C1 is actually sitting on top of 1 and C2 is sitting on top of point 3. So what is the coordinates for point 3? As you can see here clearly, it's 2 comma
what do you mean, Doctor?
1.
C1 is top, on the top of one and this.
Okay. Let me draw 3 points here. Okay, let me draw 3 points. Do you see these points? Can
Uh,
you see these points that I've just drawn? Now what I'm going to do, I'm going to pick the location of one point, okay? And then I'm going to say, I'm assuming this to be my center. This to be my center. Can you see?
I did. You did not draw anything.
I'm drawing things here. Can't you see on the right side? You're unable to see what I'm drawing on the right side? The rest of
Okay.
you,
I
can't you
can
see the
now.
graph on the right side?
Yeah. Okay.
Do you see those dots here? Let me draw those dots a little bit bigger, okay? Maybe you're unable to see those dots well, so let me draw those dots a little bit bigger. Can you see now those dots here? Those red dots? Saeed, are
Ye-
you able to see those red dots?
Yes, I can.
Okay, so these are dots. So this is my data. This is my data. Okay, this is my data. Spread. Now, when I say I'm randomly picking 2 points, what I'm going to do when I'm going to pick randomly this point, I'm going to say that this blue one is my C1, randomly picked. Okay, C1. But do you notice that below this blue point, the red point is actually still there? Are you able to see this or not, Said? Let me just zoom that in.
Okay.
Just a second. Can you see that underneath? Yeah, I'm going to delete this one and I'm going to zoom again so that you can see well. Can you see that this red was my original dot, right? Original point.
Okay, the one on X.
X,
Like,
X is my C1. X is my C1, right?
okay,
X is, and X is my C1, and it is sitting on top of another red point, right? Which means that they are different points, but they are just sitting on top of each other. So they are at the same location. They're basically at the same location.
okay,
So the point is, uh, I'm just telling you that one itself is not a center. It's just the center is located where point one is, or center two is located where point three is at the same time. Why it is important to know? You will understand. You will understand that better. Now, can you just note, take a screenshot of this on your mobile phones, please, because you may need that during your calculation. So if you need, I can use my maybe screenshot or cell phone screen or anything. So I'm just like you, I'm going to take like, just this table, image of this table. Okay, so I've just taken the image of this table because I need to know, I need to do certain calculations on the next screen. Now, what does DC1 to 1 means? What does this mean? It means that I'm trying to find what? Who can tell me what I'm trying to find?
Distance,
Between?
centroid and point one.
Okay, so what was the coordinates for point 1?
It's just 1.5, I think.
Yeah, and that is why I said I'm keeping next to me. You can see here, the table on my phone, the picture, so that I can see. Okay, and what is the coordinates for C1?
The
It
same.
happens the same,
Yes.
right? Which means that when I'm trying to find distance using what? Using,
Euclidean.
yeah, Euclidean. Let's use Euclidean. Okay, so how would you write Euclidean distance here? It will be x and x. This is x, right?
One
And this
minus
is
one.
y,
Yes.
right? So it will be 1 minus 1
Square
square
plus
and plus 1.5 minus 1.5, right? Do you all get that? 1.5 minus 1.5 square, which means that the distance between them is actually 0. Yes, what should I write in my Euclidean distance?
1 minus 1.
1 minus 1. And what about here?
1.5
1.5
minus 4.5.
minus 4.5. Okay, which is great. So you understand how we are measuring the distances. Okay, so then it becomes, the next step, it becomes 1 minus 1 is 0, right? Plus, what is on the other side?
3 square minus 3.
3, 3 square. 3 square is 9, which is the square root. With square root, so what is the distance?
3.
mm,
You see that we wrote like 3 here, right? We wrote 3 here, right? Everybody got that? All of you in the chat box, meeting chat box, please. Are you able to follow Ahmed, Hassan, and everyone else, right? So, Muhammad, that okay. So let me just repeat it for at least one more point, and then we'll go to the next step. Okay. So I'm going to clean the screen up again so that we can just write again.
the
So
next
I'm going to
it
delete.
will be 4.5
Yes.
minus
Yeah. 1.5 minus 4.5. 1.5 minus 4.5. Yes. What is it, Saeed, that you don't understand?
no, the next one, not this one.
Oh, you're looking for the next one.
Mm.
Point 3. No, I'm going to ask you now. I'm going to delete this one. Okay. And I'm going to ask you to now find me distance between, let's say, C2 and 5. C2 and 5. Okay. I'm going to write here C2. So who can tell me the coordinates for C2, please? X, Y. Do you have it? Has anybody taken a picture of this thing? Otherwise, I'll go back. No problem.
Can you go back, Doctor?
Yeah, I will go back. Don't worry. So first we have to identify C2. Okay, so what is C2? The coordinates for C2.
C2 is
What is C2?
C2.
Okay, 2 and
It was 3, I think, or what?
no, it was 1.5.
Yeah,
2 and 1.5.
1.5.
Let's try to see point number 5 to see the distance between 5. Okay, so please make note. What is this? What are these coordinates? 3 and
3 and
3
2.5.
and 2. Okay, so I'm going to write here 0.5, and the coordinates are 3 and 2.5. Everybody with me?
Mm.
Okay, so I'm going to then I'm going to erase again these 2 points here so that we don't have to write at least the square roots and everything else. Okay, so I'm going to go back here. So what should I write here in the first one?
2 minus 3.
2 minus 3 and
1.5 minus 2.5.
yeah, 1.5 minus 2.5. So 2 minus 3 is how much?
1.
1 square, which is 1, right?
Yeah.
And what is this on the other side? 1.5 minus 2.5.
1.
Again, 1 square is 1. So square root of 2 is how much?
Square root of 2.
Yeah, because 1 plus 1 equals to 2 and then square root. This is actually 1.41. Okay, 1.41. Okay. So everybody understand how to measure distances now. All of you are okay? Okay. Now what next? I'm going to say here that this is C1, okay, and this is C2. Now each point C1, which is smaller distance, 0 or 1?
0.
So I've drawn line here that C1, point number 1 belongs to C1. What about the next one? Belongs
C2.
to point 2 belongs to C1 or C2?
C2.
Why C2?
Because it is 1 or
No, look at the distance. Look, point 2, distance here, its distance is 3.16, here its
yeah,
distance is 3.
the C2 is smaller by 0.16.
Yeah, C1, right? So C1, it's closer to C1, isn't it? Yeah, this is 3, this is 3.16. Which is the smaller number?
3.
Right? So it means point 2 also belongs to C1. What about point 3? Does it belong to C1 or C2? Anyone else as well on the chat box, maybe even? If you want to use mic, Saeed, you can continue using mic, but others in the chat box, please. So point number 3 belongs to C1 or C2? C2. Hassan says C2. Do you all agree with Hassan?
Yes.
Okay. What about point 4? C1 or C2?
C2.
Do you agree with Saeed? The rest? Okay. What about point 5?
C2.
C2. What about point 6?
C2.
It means that our first cluster has only point 1 and 2, and the second cluster currently has point 3, 4, 5, and 6. So we have just almost completed our first iteration. There is one point left. What is that point left? We have to recalculate the cluster by taking the average, right? We have to find the average, as I told you. So how do we find average? Now you will see. So you can see your data here. So cluster 1 has point 1 and 2, right? Was that the case? We said point 1 and 2 in cluster 1. right? And the rest of the points are in cluster 2. So what did I tell you? How do you find the new cluster center? Anybody remember what I said? Replace the K center with new averages. So let me show you what does that mean. Point 1, sorry, cluster 1. What are the x values in cluster 1? Can you see it here? 1 and 1.
Okay.
So you take average. 1 plus 1, 2 points divided by 2. New x value is 1. What
Mm-hmm.
about y? What about y?
3.
3.
1.5 plus 4.5 divided by 2. So this becomes 6. 6 divided by 2, 3. So your new cluster center is actually 1, 3, which was not 1, 3 before. It was 1, 4.5 the last time, right? Just like this, look at the second cluster. So you can see here 2 plus 2 plus 3 plus 5. 2 plus 2 plus 3 plus 5. So 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 4,
3.
it's 3. 3. And then 1.5, 3.5, 2.5, and 6. 6, 7, 8, 9, 10, 11, 12, 13, 13.5 divided by 4, 3.75. So this is your another center. So this is first center is 1, 3, and the second center is 3.3, 3.75. 375, sorry, my bad. 3.375. So you have your new clusters. Now what do you do with these two new clusters? The new cluster centers, sorry. What do you do with these new cluster centers? You have just completed your first iteration. Let me remove everything out from here. So do you now understand that how to calculate distances? You just calculated distances.
Yes.
And you know how to assign point to a particular K center, right? And you know how to compute averages and replace. What next? The next thing is
We do it
you
again.
iterate, you repeat the process. So if you know one time how to do it, you have to just do it again. For example, if you see here, let me remove all of them. So for example, our one of the centers is 1, 3, right? So you just have to find the distance of this point with 1, 3 now, right? The new center. And again, you can see here, you'll find new distances, all the 6 points. But this time you don't see any 0 point here, right? Because now cluster is not sitting on top of another point, right? So you find distances. So now let's at least make a decision to which one belongs to C1 or C2?
The first
C1.
for C1.
C1. What about point 2?
Also C1.
C1. What about point 3?
C1.
C1.
Point 4.
C2.
Point 3. Point 5. Sorry. Point 5.
C2.
Point
2.
6. But you notice that this time the cluster shape has changed. Previously it was 1, 2, and the second one was 3, 4, 5, 6. This time the cluster 1 is 1, 2, 3, and the second point is 4, 5, 6. Can you see that? It means that cluster has changed. So now what you have to do is again you find the cluster repeat. But one thing you notice is that it's a very data or calculation heavy approach. Can you see that? That even for a small problem with only 6 points and only 2 attributes x, y, you have to do a lot of calculations. So you must be wondering, what we will do in the exam. So in exam, we might ask you to not maybe have 6 points, maybe 5 points, 4 points, and do one iteration, something like that. Okay, I cannot guarantee until the course leader sets the exam, but do you understand the expectation? But why are we doing that by hand? Simply because now you understand how the algorithm is working. That is why we are solving those small problems by hand. Okay. Before before I go further, okay, before I go further, uh, and I'm going to, in fact, let me continue and then I can talk about the other thing, okay? So one of the things in terms of general consideration is that, as you can imagine, because we are using Euclidean distance, it does not work on categorical data. Categorical data means like male, female, genders, or colors, red, green, blue. How would you take the Euclidean distance between red, green, and blue, right? You understand that? It only works with real numbers. Real number meaning that numbers like these. So all those attributes with real numbers can only be used in k-means. If you have categorical data, can we still do it? The answer is no in its current form, but yes, if we convert the form into something else. We will talk about that, in one of the future lectures. But the answer is we can still do it. But what we will do later and what we will learn here is that we will convert it into something called numerical equivalence. So for example, if you have to say yes and no, and yes and no, so I can use like one and zeros like that. But it's not that simple. We'll talk about that, how that thing is actually done. Okay, so we'll talk about that later. So far so good. I think you should be able to see that. As you can see that it is sensitive to outliers. Why? Because an outlier may result in big Euclidean distances, which may affect your calculations. Especially the centroid, because centroid, new location of centroid is the average, right? So if you have an outlier in your cluster, it means that that outlier may affect it big time. So we need to be aware of that, especially when data points are small. One large outlier, it may have a very big effect. But if you have very large data points, 10,000 points, and few of them are outliers, maybe it will not that have a big effect. Okay, there's no way there is no way to tell which attributes are significant in determining the form cluster. So so it is very difficult to say whether X is dominating or Y is dominating. So we cannot tell that. We can ignore a particular attribute. Okay, so it means that we are more responsible in terms of interpretation. But let us just go there and look at one more example. In fact, what I can tell you here is that if again we have how many data points? We still have 6 data points with but 2 different values. So what I normally suggest is, and I would suggest the same to you during the exam, to have a sense of the outcome. What you can do is you first actually plot your data. You plot your data, okay? You can see here that I'm saying let k equals to 2. But even and I have randomly picked C1 and C2. But what I would suggest is to plot it first. For example, point 1 is what, point B is, this is point B. You can see here 1.5 comma 2. And this is 2.2 comma 1. This is point A. Right? What is point C? 5 comma 7. This is point C. 3.5 comma 5. This is point D. This is point F, and this is point E. Okay. Yeah, I think you can see that, right? But I think we can clearly see that it seems like there are 2 clusters in our data.
Doctor, how did
Yes,
you plot these?
I just checked. See, A is what? What is A, Said?
2.2 and 1.
Okay, so this is attribute 1, and this is attribute 2. Okay.
Okay.
So you can see here A is this is 2. Can you see this is 2?
Yeah.
So this is around 2.2, and this
Okay.
is around 1. Yeah. So I just kind of labeled them by looking at it. Okay.
Okay.
Okay. Now this second example is just for you to now practice. So what I have done here is that I have given you as an exercise to solve. Now, would you like to solve it now? Would you like to quickly solve it? Maybe in coordination. By the way, when is your quiz?
Wednesday.
No. Not our quiz. I mean the quiz today, in terms of how much time we have.
At 7 p.m.
Yeah, so we can go easily. Okay, let me come back to it. Let me come back to this problem. Okay, because I wanted to cover something else as well. Okay, uh, we will set a time and then we'll see how far we can go. But let me just talk about few more things and then we'll come back to it. Plus, in fact, I wanted to tell you that I have put two sample problems. Okay, I have to put two sample problems on Blackboard now today. Okay, do not look at because it's an ungraded assignment. It is basically I want you to try it out before the quiz. That's what I want. Okay, and you have any concern, please talk to me. Okay, so these are the two thing. Now the second one is it actually belongs to k-medoids, which we haven't covered. So you can use actually the same the two examples with k-means. You know, once we are going to do k-medoids, you know, the next one, then you can use the same two problems with k-medoids. Do you all understand that? Two problems are there. You can solve them by k-means or k-medoids, but you know, these are there for practice problems. Once you have done it, I'm going to then share the solution to you later. Okay, because this solution solving it is important for midterm, not for the quiz, right? So I'm going to inshallah share the solution later, but I want you to solve it, and I most likely will create a submission so that I can see your solutions. Okay, but let me just go back and finish some important discussions here. Okay, this lecture, let me just upload this lecture because I just received it from the course leader now. Let me just give me a second, please. So this other lecture is just an added thing which is not included on the on your Blackboard. So I'm going to quickly upload it so that if you want to download it now, you can download it as well. Okay, just give me a second. Okay. So I'm going to upload this lecture now, so you can just give me a second, please. So edit, let me just edit this. Okay. Can you please check if this lecture is available to you? It's showing here.
Doctor,
Yeah, I need to submit it. Just give me a second. Yes,
our quiz is on Wednesday, right?
yes.
Okay, thank you.
Are you able to receive the announcement, by the way? Have you seen the announcement? Have you seen the
I will-
announcement?
Yes.
We will check it now.
Yeah, because somebody was telling me that they were unable to see the announcement. So if you go, I've, by the way, shared it with Muhammad as well. But you know, the details are available on both sections. You know, the quiz one by the name quiz one. Okay.
Yeah. Thank you.
Okay. Okay. Sure. So let me just go back to this lecture again. We just have few more things to cover. In this lecture, last time I keep telling you that, okay, I'm giving you K, I'm giving you K, or you can plot and you can judge what is the right K. But now I'm going to tell you how to select optimal K in K-means. There's actually a method behind it. Because in smaller data, you can just use, like plotting or something, but it doesn't work when your data sets are large, okay? So what you do is, I'm going to show you how you can select optimal K using some methods. And then I'm going to just discuss something called K-means plus plus, which we are not going to solve in this class, but I'm just going to discuss a version of K-means that works faster, okay? So let me just start by talking about how to select optimal K, and then we're going to define K means plus plus, K means plus plus, and then the practice problems. Orange you have done, you can use the same data to do it on Orange as well. I'm going to talk about that later. So K means I don't need to recap. I already showed you, what are the steps that you initialize cluster by picking K centers. You find distances, you measure centroids, you update centroids. Now, one of the concepts that you must understand is called the concept of convergence. Convergence meaning that when you go through first iteration, second iteration, third iteration, eventually the center will stop changing, which means that when the center stops changing, this is what you call convergence. It means that center is not changing anymore. Okay, so everybody understand what convergence is? Convergence is the concept that every next iteration, your center does not change anymore. So then basically you're saying that your results have converged. So this is where you stop. Okay. Okay. Now, one of the things I want to ask you, in fact, when I'm asking you that you have to randomly pick centers, when I say you have to randomly, before that, when I ask you to pick number of clusters, that seems to be a very awkward approach, right? You randomly pick any number of centers, 2, 3, 4. It doesn't work like this. It has to still make sense. So I showed you that we can draw a graph, and we can see, maybe I can see 2 clusters, 3 clusters I can pick. But if you cannot draw, graphs because it's 3-dimensional, 4-dimensional, large data sets, then I'll show you that we can make use of 2 techniques. One of them is called the elbow method, and the other one is called Silhouette method. By the way, both these methods are just for your normal knowledge, which means that we are not going to solve it. But at least you should know what elbow method means and Silhouette method means, because when you're going to go and trying to solve that in Orange, it will ask, which method would you like to pick? Do you like to use elbow method, or would you like to use the Silhouette method? Okay, so these are options available in software, and you should know how elbow method picks things and how Silhouette method picks things. Okay, so let's see how elbow method works. It is one of the most commonly used, as they call, naive method for determining optimal number of clusters. So it helps you pick the right K before you actually use K means. Okay, so it helps you pick the number of clusters before you actually solve. So the main idea here is to calculate within each cluster the sum of squared errors. What does that mean? It means that, all the distances that you saw in each cluster, you remember we were finding distances with one center and the second center. Let me just draw it, which will be easier for you to follow, so that you understand it better. Let me just go full screen again, and then let me just draw that. Okay, so imagine we have 2 clusters here, one of them here, and the second one is here. Okay, now this is your center, and this is your center, imagine. Okay, and these are some other points. So I'm only saying that we have 2 clusters. Okay, this is 1, 2, 3, 4. So what am I drawing? I'm trying to draw distances of points with clusters that are associated with it. Let me just remove this point. Let me put it here, okay? Because it will otherwise it will look messy. Okay, so what you actually see is distances of each point with its own clusters within the data. Okay, now read this again. Within cluster, sum of squared errors. So what this is like error number one, this distance is like the other error, this distance is like the third error, this distance is like the fourth error. So what you're doing is you're squaring those errors up and then adding them up. So you can see here that
Doctor,
I can sound, yes.
it's not obvious because the point is too small. Can you zoom in and
Okay, let me try to zoom in. Okay, so do you see this center? Do you see this center? This is cluster center. And in this cluster, how many points are there? 1, 2, 3, 4. Can you
okay.
see those 4? So distance of each point with its cluster is called an error in this elbow method, which means that the closer you get, the smaller will be the error. Do you understand this so far? Now what they are asking for is not just the error, but you square the error up. Meaning that, if it is distance is 1, you actually do 1 square. If this distance is 2, then you actually do like 2 square. So let me write this, because when I write distance, for example, this is 1. Okay, this distance is 1.5. This distance is 2, and this distance is 2 as well. Sorry, my pen is misbehaving. So what you do, you square them up. So 1 square plus 1.5 square plus 2 square plus 2 square, right? And this becomes like the error for this cluster. And then exactly the same you repeat here. So this becomes like all the sum of all those errors become the sum of, the squared sum for this cluster. Now imagine the same problem, and I'm going to delete some, I'm going to delete extra things here. Okay. Let me draw it again. Let me draw it again. Let me draw everything up again. Imagine the same problem. Oops. Imagine the same problem, but this time I try to draw bigger circles, okay, so that you can see those points better. I'm trying to replicate the same problem, okay? I hope you're able to see those points now better. Now imagine if I take k instead of 2, if I take k to be 3, k to be 3 with these centers, what will be the effect on errors? Yes, what will be the error effect on total errors? As compared to the last time? Yes. Do you remember what was happening the last time? This center wasn't there. So you're measuring this distance with this one, right? Big errors. Big errors. Can you see big errors? So when you use a third cluster center, those big errors turn to small errors, right? Which means that instead of 2 clusters, when you move to 3 clusters, it gives you less errors.
How?
I just showed you. I just drawn the distances. Can you see the sum of these lines? All these lines are small. These errors are small, right? Previously, when you were not using this center, you had to measure it with this one. Do you see this big error? Can you see this big error? I don't know what this color, orange, right?
Yes, yes. Okay.
Can you see that this error is so big? This error is so big, right?
Mm-hmm.
So which choice is better? The one with the smaller error, the one with the smaller error. So if you're choosing 3 clusters instead of 2 clusters, the error size becomes small. So the elbow method basically says that
But this is
you
too big, the 3K.
what is big in 3K? So you have basically in 3K you have K equals to 3. You have instead of 2 clusters, you have 3 small clusters.
You mean the 3
For
points?
first, second, third. So you have 3 clusters, isn't it?
Mm-hmm. Okay.
Before that, when you were using 2 clusters, you had if you remember, this was 1 cluster,
Mm-hmm.
and the second cluster was this big cluster. Now, let me
Okay.
ask you something. Yeah, say again, say.
So now they separated. It's become
Yeah,
3.
I'm competing. I'm trying to see whether 2 cluster is better or 3 cluster is better.
Mm-hmm.
So, first of all, can you tell me what are we trying to achieve in clusters? Similarity or dissimilarity?
Similarity, I think.
Yes, of course, similarity. So when you break 2 into 3, similarity within cluster has increased or decreased. When you use one big cluster, are
Uh,
they like really similar? When I see one big cluster like this, are these points like really similar to each other?
no, not similar.
That's why we are breaking them up so that the error becomes small, so that they become more similar. Okay. So this is basically the same formula, the Euclidean distance basically formula, but this time you square them up, and then you see total error here plus error here plus error here, and then so this is basically the same Euclidean distance. So you try with 1 cluster, you try with 2 cluster, you try with 3 clusters. Now, as you increase the cluster size, there will be no big change after that. You can see here that after 3, there is no big change. Can you see that? Total error was 8,000, total error was 20,000, total error was like maybe 1,000 something, and then it becomes flat, no big change. So what
Mm-hmm.
is the K would you like to use? As you can just use your common sense. Then when it becomes flat, you pick the smallest K. You pick the smallest K because you're looking to group, not ungroup, right? So elbow method says pick this elbow, meaning that when the error starts to come down, pick the one that suddenly after that there's no change.
Mm-hmm.
Okay, everybody understand that what is like the elbow method? So you keep trying several in this diagram. We are trying K 1, 2, 3, 4, even up to 10. But after 3,
So
there wasn't any
mm,
reduction in error. Yeah.
we're trying uh, to to stabilize and make the smallest error.
Not just smallest error, but when the error doesn't start to go down any further, not big change, then we stop.
Oh.
After 3, the change in error is very small, very small. So this is where you stop. Okay. So this is basically what you call the elbow method, and okay, and that gives you, for example, in this case, 3 clusters. They are all, you can see that they all are very connected clusters. Similar looking. Silhouette method, on the other hand, does not look for distances. They basically look for, and not going to show you math here. I'm going to just show you some just I'm going to explain this concept. There's something called cohesion. Cohesion is opposite to dissimilarity. Cohesion is like the similarity. So cohesion is a measure of similarities. So if more points are closer to each other, you have high cohesion. And the opposite of cohesion is separation, which is basically the error that I showed you last time. So, but what they do is in Silhouette value normally ranges between +1 and -1. +1 meaning that they are very close to each other, and -1 meaning that they are separated from each other. Okay, so again, what it does, it tries cluster one cluster, two cluster, three cluster. Which number of cluster is showing you the highest Silhouette value? Can you see on this map? Now I'm going to draw this Silhouette value. Right, this is the highest value. So again, for the same problem, you can see that elbow method and Silhouette method is giving you the same value. Highest Silhouette value is occurring at cluster number 3 number of clusters.
Doctor, it's a bit confusing.
Yeah, basically they are trying to see how close each one of them look, okay, within each cluster. Okay, and this Silhouette method says that your number is varying between -1 and +1. Okay, +1 meaning that they look very, very close to each other within cluster. -1 meaning that in cluster they are very, very far from each other. They are far from each other. Do they look close in this cluster? Do they look close? The point. Do they look close? Sorry.
Yeah.
They look far within each cluster, right?
Why?
But look at here. All points are very close. They are like very, very close to each other. Very close to each other. So that's why it has very high. When you see a situation like this, you'll get a Silhouette score of +1. When you see a cluster, when they are too far within a cluster, you get -1. So do you see? Now read the graph again. When we use only like 2 clusters, Silhouette score was this much, 0.75. But when we use 3 clusters, Silhouette score went to almost 0.9. When we tried 4, it came down again, to 6.5, and then almost at 6 it becomes very, very, very low, right? So that is why we pick the cluster which is giving you highest point on the graph. Okay, highest point. This is the highest point on the graph. Do you all agree that there is nothing higher than this? Right, so this is you just check what is the cluster number, and then that's the cluster number. Okay,
so we pick the highest.
You pick the highest. You see which cluster number is giving you the highest Silhouette value. Okay. Okay, now just one last thing and then we will stop. One of the things is that I keep telling you that you have to randomly pick. Let me just go back to our previous example. Okay, I'm going to go back out. I told you that in clustering, we randomly pick 2 points. Okay, to start off with. Now, what is the problem with that? There's a big problem with that if you just randomly pick. Okay, let me close this. The chat box. Okay. Now, what problem do you see when we randomly pick points? For example, randomly, I pick this as my first cluster center and this as my second cluster center. What problem do you see in this? Because it's random, right? Randomly, I can pick any 2 points for k equals to 2.
You mean
what is the problem you see?
Some points are close, some points are far.
No, it doesn't matter. The problem with this thing is that if you pick bad points randomly, the number of iterations become too much. Because you go into iteration. I told you pick any 2 points and you do k-mean clustering, iteration 1, iteration 2. Maybe after 2 iteration you get your clusters, right? But if you pick bad points like this, maybe you have to do more iterations. Instead of 2 iterations, 20 iterations before it goes and picks the right one, right? So choice of points is important, because if 2 points are already close to their centers, they will go to the center very quickly, but they are far, so it will take time for them to go to the centers, right? So that is why yes.
Uh, I did not understand. Could you repeat, please?
Okay. Okay, let me delete everything. Where do you see their natural center site? Do you think that this looks like the natural center for the two clusters? If this is one cluster
Mm-hmm.
and this is another cluster, do you see that this is the natural cluster,
Okay.
right? Now imagine if these are the two natural clusters, okay? Now if I start here as my C1 in the beginning, okay?
Mm-hmm.
I start here in C1 here and randomly again pick this as C2. In the next iteration, it will move from here to here to here, even maybe in one step or two step, because it's so close, right? The clusters in next iteration will move to those actually natural locations
It will move
very quickly.
to where?
Nat- to the where it should be. It's the actual natural centers. Where we wanted to find. We want them to find where are those points. So but iteration with iterations, it will take few iterations to move from here to here. But imagine
Can you do an example?
if let's do that separately, because many people are sitting here. I cannot show you because I have to do two separate iterations with two different points. So it will take maybe 2 hours to show you numerically. Okay.
Okay.
So but let me show you another example. Okay. Now imagine that we still understand that this looks like one cluster
Okay.
and this looks like another cluster. Okay.
Mm-hmm.
But this time I have randomly picked these 2 points as C1 and C2. C1 and C2. This is C1 and C2. Okay.
Okay.
And now this was supposed to be the center, and this was supposed to be the center at the end of your calculations. Right. One of the C2 will take not time to move, but this time this is so far from the center that it will take more iterations to figure out that I have to go there, as a
Okay.
center. Right. So it takes very long. So randomly picking points is problematic because of this reason. So what do we do? So we use, some people have developed a method called k-means plus plus. What they do is, and k-means plus plus works with only with very large data sets. It means that you have 10,000 points. Okay. So what you do is, because algorithm takes time to run, so what they do is they take a small sample data set, meaning that instead of 10,000 points, they randomly pick 200 data points or 500 data points, and then run k-means onto it, because running on 200 points, it will run very fast, and then it will identify you centers. Now these centers hopefully are close to your actual data, cluster centers. So they start from these two points rather than starting from random points. And then because of that, because you're hoping that you're close to those points, so the k-means plus plus will then converge more quicker. It will run more quicker. Okay. Okay. Now I've already shown you k-means last time, in orange, in the last class, BI class. So it's just showing the same thing again. What I have already told you is that the previous one has a new problem to solve for you to practice. Okay. And then I have given you this file. So 3 problems that you can use to practice. Okay. Now next class, I'm hoping that you would bring the solutions to these. Otherwise, I can put 0 grade assignments on Blackboard as well, so that I can see how you're able to solve. Okay. Because there will be a lot of marks on these problems. It's like half your exam contains, if it is like 20 marks exam, maybe 10 marks will be, or maybe even more. Uh, More will be basically, more will be on, more marks will be on this clustering. So I need to make sure that you are able to solve these problems by hand. Okay. So if there's, do you have any questions now? All others, all of you?
Doctor,
Yes.
do you have time tomorrow or Tuesday that I can arrange a Zoom session with you because I have some questions.
Later, you mean?
Yes.
Yeah, later, sure. You can request a Zoom session. I'll create and we can find a time. I can give you.
Are you available tomorrow or on Tuesday?
Tuesday is fine, I think. Not tomorrow, because tomorrow I have class, or tomorrow afternoon is also fine. By the way, is Hisham here? Hisham Ramadan. Anybody know Hisham Siha? Muhammad, do you know Hisham Siha? Siha. Okay, so you need to help me solve this problem for me. Okay. So what is first of all the coordinate that, Saeed?
No, nothing.
What did you not pick?
You know,